Hey guys, welcome back to my channel. I am AttiDude back in another video, and in today's video we're going to be learning about math in C#. How to use math and some functions like minimum value, maximum value, square root, then cube root. You can even use round function, floor function, seal function, and a lot more. And some more functions like cosine, sine, AttiDude, absolute values. And we're not gonna go too deep inside that because we're gonna get a whole lot of different functions. We're just gonna write some basic functions, just like that. If you haven't liked or subscribed my channel yet, do it now. I'll provide more content like this. So without any further ado, and let's dive into a class that we created in our last video, and I'm gonna delete the whole thing, the whole player class. And everything inside of this except of console.readLine. And now there are a lot of different functions that math in C# that is provided by the .NET SDK provides to us, like math dot, and you have minimum, maximum, pi, square root, round, absolute, acos, h, asyn, asyn-h, aten, aten2, aten-h, a lot of different functions. You can even get truncate, scale b, round. Actually, we discussed about round, power, or exponent. That's a pretty good function, but because we calculate power every now and then we can get logarithm, floor, exponent. We can get e, which is the logarithm base, copy sine, a clamp, ceiling, cube root, and a lot more. You can even use mathf. If you use Unity, you do mathf like this. But if you're just using the normal C#, then you can just write F capital. You have to write that because that's the class that provides all the different features, functions. We have these. A lot of different functions that we can get. And I'm gonna use primarily of math. I'm gonna write min or maybe max if possible, and you can see we have bytes. Then if we just scroll this down, we have decimals, we have doubles, we have floats, we have ints, we have long. S byte means short byte, short, U int, U long, U short, and again round to byte. As you can see, you get almost like 11 of different types of variable or variable types. And in here you can see the summary or the comment says provides constants and static methods for trigonometric, logarithmic, and other common mathematical functions that of course we need. And first of all, I'm gonna pass in 5 and 6. That's the most basic ones which I could get. And you can write console.writeLine, wrap this whole thing up, and we expect to see 6. There we go. And now we're gonna do min. 5. Yes. And they're not just these. You can get many more like pi, whose rounded value we know is 3.14. Okay, we have pi. We can even do square root. And the number that I'm gonna pass will be 121. I know the square root of 121 is 11. That's it, play and see. Ta-da! We got 11. That's what we expected. You can write CBRT, that means cube root. And kaboom, we got this. Don't worry because you're not just able to calculate. You're gonna type in 343. I know, it's 7. Yes. So we got these. There are many more functions. You can do round. First of all, we're gonna look at absolute values. If you don't know absolute values, I'm gonna tell you absolute values are like, as you can see, that absolute value, but it doesn't tell what an absolute value is. We're gonna understand that. Absolute value is nothing but whatever the number you have, it is always gonna be positive. Like if you provided -5, it is gonna give you 5. If you are gonna provide it -10, it's gonna give you it's gonna give you 10, not -10. If you provide it like 1.5, it's just gonna provide 1.5. Let's write -1.5 minus 0.15 f, like this. Let's just hit this. Wow, we got absolute value of this. Actually, I don't want this. And if you want, you can just do like this and kappa. There are several different functions which you're gonna talk about. Like we have clamp. Clamp is like a value that we need the most while making like something a value that never ever has to go bit more or maybe less than the decided range. Like if we are making a character controller, then we want the camera to only look up and down to a limited extent. Like we have up at the top 60 degrees and down at the bottom -60 degrees, or I think it's inverted. I don't know about that, but that's how it works. We clamp between those. It's really simple. You can do this is type in the value, and what you're gonna do is to create an int, and I'm gonna name this rotation x. X basically is the value on which we rotate usually, and for rotation x, the value that I'm gonna pass will be like 90. We can go right here at rotation x, and then the min and max values. I'm gonna pass in -60, 60. So let's just hit play. Cable, we got 60, and if we were to write -90, it still gives -60, and if we write -45, it gives us -45. because we know we have clamped it. I just want to go it down, scale this down. No, I don't really want. Oh, okay, that's what I want. Such like this. Okay, we have rotation working. That's how you do with clamping. Now the next feature that we're gonna explore will be exponent or power. And we can basically write math of the exp, and we can just write some variable like 10. Then if we hit play, we get this. Ooh. What is it doing? Let's just say raised to the power 1. I don't know if this value is the value of logarithm, and basically it works like this. I think it's really the logarithm, so we're gonna leave it. We're gonna use power. Exponent is used when you want to work with logarithm, the power of e for short. Here you're gonna pass in the y. That y is gonna be, I think, 10. 1 raised to the power 10. That would be just like this. I think it should work. Yes, we got. What does this tell? The first one number is basically, it just does this. The number x raised to the power y. It just basically does this. And if you don't know what powers are, I recommend you watch any Wikipedia page about power, or I'm just gonna explain you what actually is power. If you multiply a number by a specific, it's not like multiply a number with power. It's like if you have a number with a specific power, like we have in our case 2, and that number is 10, then we are multiplying that number by itself the y number of times. Like we have 10, we're multiplying it by itself 2 times. That means 10 into 10, and that will result us 100. And if we were to write 3, it will be 10 multiplied by 10 multiplied by 10. That will result to us in giving us answer as 1000. It works like that. And if you have the power of 0, it's just gonna return 1. Let's test. There we go. It returns us 1 because it's the law of math. You cannot change it. We looked at many of these. E is basically the logarithm, natural logarithm. You can even work with these values. I recommend to just mess around with these values, not in your actual project, but in your test project, because I know if you were to work in your original project in which you work like a lot longer, then you may end up messing around with many values and just messing around, and you'll just end up losing your work. So I just better recommend to use math only in test projects. If you don't know this, if you know it really well, You can use it in any project. It's your choice. You can even do magnitude, logarithm, as we have. Let's look at rounding, flooring, and sealing numbers. Let's just first look at floor. What actually is floor? First, open up Microsoft Whiteboard to make you understand how the whole things work. So let's just say we take in a pen. We have two of these. This is 0. It's going way too big. Like you have 0, it's too thin. And you have 1 right here, like this. Then what you need to do is, for example, you have a number right here. Somewhere here, it's like 0.5. I know it's hard to write with a mouse, optical mouse especially. So, I apologize for the bad handwriting because I'm writing with a mouse. Okay, so we have a 0.5 value. Then what floor will do is, if it is greater than any number, it is greater than 0, then what it will do is to round that off to the number which it is greater than. In our case, it is 0. So I can write floor. It was better if I were to use any other software. Let's just say floor. And floor does this. Let us also understand the theory of one more concept, which is the concept of ceiling. And that basically means is that if we have this value, let me just do it a little bit like 1, it's looking like a line. So if we have 0.15, it just determines which number is greater than this. In our case, it's 1. So what it does is that it just basically first floors and then adds 1 to it. If you don't know it this complex way, let's just say it rounds off the number to 1 greater than that. And that 0.5 will be rounded to 1 in our case if we seal that. Seal. And if we have rounding, then what it will do is that it will round off accordingly. If it is greater than 0.5 or if it is 0.5, then what it will do is that it will seal. If it is less than 0.5 of that number, then it will just do floor. And it's not necessary that you have 0.5 right here. You can even have 1, 2, or any number, basically any number. And that's how these things work. I'm just gonna disable this and let's just hop it back into Visual Studio. And let's see, math.floor. We need to pass in the decimal value, which in our case, I'm gonna pass in 0.5. We got 0, right? That was what we wanted. Because we know if we floor 0.5, we're getting 0. Let's try with 2.5. We got 2. Okay, we have 2, and let's just try sealing. I know it's gonna give us 3, yes, because if we seal any number, as we saw here, it's gonna add that to the number greater than that. I don't want to move. Number greater than that. In our case, it's gonna be 1. So if it is 2.5, it's gonna make that number greater than that, and that will be 3. This was math_of.ceiling. We can write math_of.round. We got 2. I think this works a little bit strangely that we learned in our math classes when we were small children. What we were taught in our math classes was that if the number is greater than 0.5, then we added that. Then we just seal that. If it is greater than 0.5, we floor that. In our case, in the round function, I don't know why, but it is like if the fractional component is has to be between the integers, one of which is even and the other odd, then the even number is returned. Note that this method returns a double. Okay, I understood that. The even number will be returned, like you have this right here. It works like if it is between those, like we have 0.5, then what it will do in the math.round function is that it will just round to any number that is even. For example, if we had 2.5, 2 was a even number, we know it is an even number, so it will just floor that. And if we have 3.5, we know 3 is an odd number, it will seal to that, to 4, because we know 4 is an even number. I don't know what happens with math_of.round. It's float in math_f, because I think the F stands for float. Let's see, it works the same way, but instead we have to pass in the float values, but before we used to pass the decimal values. It's okay if you write F. So this works like the round one works like that. And let's see if we have any other function. We have 8. We have cos. That means cosine. We have sine. We have 8. Logarithm. And more of these. Personally, I don't understand cosine, sine, logarithm, 8. I don't know what these are, but I mainly use the other functions like pi, square root, round, and if you go sine, cosine, tangent, all these concepts are actually a lot complex for me to understand, so I've left them for future. In math_f, I don't know where it was like positive infinity, the negative infinity. We even have a VB math, Visual Basic Math. We have randomize. We're not going to use that math. I'm just going to remove the namespace space right there, and I saw somebody negative infinity, positive infinity. It's like double dot negative infinity and those variables like that. You don't actually see math dot infinity. If you use Unity, then you get those, but I'm not currently using Unity. I'm using the standard C#. So if you want infinity, you can write float dot max value. It's this. Positive infinity. Let's print this out. Oh wow. And if you want something like a variable to have its max value, you can actually go and grab like max value, min value, like that. And all those with star are also gonna be in here, and the list that is without star, and these star ones represent that these are most commonly used. If you were to write double dot infinity, positive infinity, it's gonna give us something weird. And that weird thing is this symbol of infinity. So you might have expected to give us a number which is infinity, but it doesn't actually give. Even I expected that on the first go, but it doesn't do that. It doesn't actually give you infinity. You can even have negative infinity, which is equal to minus infinity. You can even check if a number is negative. One more function that math provides is sine. I'm gonna pass in any int value. I'm gonna pass in -1. It will return as -1. Let's say -10. It still returns us -1 because we are extracting its sign, and we are extracting its sign, so it will return -1 if the sign is negative, and will return 1 if the sign is positive. Let's say if we have 0, it's gonna give us 0 because we know 0 is neither positive nor negative. There are a lot of different functions that you can get. I recommend you explore that. And I know most of the functions we're not gonna use that. I can even use copy sine. Div rem. Division remainder. I think it's that. Fuse to multiply, add, and you're gonna get a lot of different functions. If I just go ahead and explain you, the video is gonna be extra long. It's already like 30 minutes since I'm recording, and there are a ton of different functions which you can of course use. They are given by Microsoft, the creator of C# and the .NET SDK. So that's it for today, guys. If you haven't liked, share, subscribe my channel yet, do it now. I'll provide more content like this. I am AttiDude signing.